Greetings, Ivis. Greetings, everyone. Daniela, Alfina, Frederick, Onyema, how are you? Thank God. Greetings, how are you?
Good evening, sir. Good.
Good evening, sir. I'm fine, sir.
Morning, very good. Today
Good
we
morning,
have
sir.
got one of the most exciting sessions. I purposefully tailor-made it for the benefit of the majority. Right, I think you have seen what I have advertised. We have invited Try, by all means, to make sure that anyone you know, they receive the link now and join. I apologize for being late due to a lot of activities that are happening. But I'm excited and I thank you and thank God, thank Intersect for this platform. We are here now. It's better to be late than never to be here. Okay, let's just give it a couple of minutes. Let me just check that I have sent to most groups, because sometimes, when you do something in a hurry, there are some couple of mistakes here. Right. Let's go here. Right. Meanwhile, we are waiting for people to join. I'll just start. Let me send you the link to today's presentation. I want to see how much we can be interactive on this most important presentation. It is our presentation. So here is the list, the link, sorry. So you can click that link, just be browsing it, write down questions, comments. If you want to say something about a certain section, you are welcome. The Intersect Developer Experience Working Group is a platform and as well as an opportunity for us to network, to catch up, to brush up all issues that relate to development. The purpose or aim is to improve the experience. It is quite fortunate that the developer language for the infrastructure and smart contract capability of Cardano is Haskell. Haskell happens to be a pure programming language, very mature, developed over 30 years all over the world. It has been an academic product. I mean, mostly darling. No, when I say darling, academic universities, mathematicians, logicians. You see, this is a language that has been manufactured to improve on the weaknesses of other programming languages. I hope today's session, you will carry a lot home. The first and foremost thing that you are going to carry home is this tutorial that I will be posting it here. Okay, there we have it. Welcome, Apula. Please, you should invite those colleges that are interested in this so that they come and see live. Okay, I am going to start now with all of you. My wish is that you enjoy it very well. That is my wish. However, if you find it very technically up there difficult, remember, we are all mathematicians. We've done basic algebra. The mentality is along that. So we are going to make sure that everyone understands and gets something out of this. So let me just send the picture to show that we have started. Then when I come back, then we can start. Meanwhile, go through the link that I have sent to you. Browse what we are going to cover. See what you are familiar with, what you are not familiar with, and start enjoying before we start. All right, let me just notify our beloved people that we have launched the rocket. I call it the rocket. I don't know whether we are going to the moon or to Mars. Are we going to land there? Definitely we are. Let me just get to the main groups there. And the other thing is, please, this takeaway, take it to those who didn't attend and then show them. Go through this with them, because it is not going to be the first and last. Several of these things are going to be coming along. I think from my side here, I've notified everyone. Daniela, please, if the French-speaking community is a lot here, we need to accommodate them. Or if there are other communities, we need to accommodate their languages by interpreting. Language should never be an issue on what we are doing here. Right, so I am starting now. Welcome everybody to Intercept Developer Advocate. This is a developer experience working group. I've said our objectives is to make sure today you brush up a lot of concepts that are on your fingertips on Haskell. I have shared it with you there. Be patient. I remember when I was in high school, you see, one of the subjects that used to scare people was mathematics. But I think now all of us as adults, we realize that those most scaring things are the ones that are most useful. And we will benefit a lot. But above all of us here, we are going to benefit on what I call logical thinking, seeing how other things have been done. All right, let me start. I'll start sharing here. Those who just came now, here is the link. As I go through it, sometimes you get disconnected as we move along. So make sure that sacrifice 1 hour today on what I am posting here. You will need it more than water. I don't know, more than oxygen. Let's say so. Right, there we go. We are launching our rocket now. I have prepared this, summarized some of this. Where do you find this if you want to go into details? Right, you can come here to the Coxygen.co Universities, a deep dive into Haskell Bluetooth. Here you click Haskell lessons. Okay. We have got videos from experts IOG. There you see them there. I have targeted, right, 17 semigroups, monoid, functor, applicative functor, and monoids. Everyone here, whether you're a developer or not, believe me, this is coming from mathematics algebra. Let's enjoy it. So this is where you can find it. And when you enjoy doing this, 17, 18, 19, 20, you can take the quiz. See how nice it is. There are very nice quiz sessions here you can take. That's what we did in mathematics. We had exercises to do. And after doing those exercises a lot, we came up with a lot of intrinsic happiness and satisfaction. All right, let's start. Our topic is semigroup. It's a Haskell programming language, which is a pure programming language. It has influenced all other programming languages all around. So we are going to tackle it very quickly and then discuss semigroup, monoids, functors, applicatives, and monads. Right. The root of all this is algebra and mathematics and the category theory, the sets. This is what gave birth to this. And then Haskell has been modeled and manufactured since 1930s by Alonzo Church. I think we have come across this name and we are familiar with lambda calculus. That's a very interesting for all of us. Okay, all right, let's start with number one. I'll run through, please. You can also have it on your side. What is a semigroup? A semigroup is a type with an associative binary operation. Right. I will look at this example to say, what is this talking about? When you talk about associative, I've got three elements here with an operator. This is a binary operator for now, which is less than, greater than. Can call it whatever. Let's call it diamond operator. Can replace this with something like plus, with multiplication. When I group the right side, let's look at the left side of the equal sign. When I group the right side, do the operation, and then later do the operation with the last value, it is the same as grouping the right side and then doing the operation to the right. We call this associative law. Right. So this defines the semigroup. It follows this associative law. You'll see a lot of it. Now, to those who are new to Haskell, what is this? What I have underlined here is what we call a function. Right. If you go to mathematics, what is a function? You will know a function is a relationship with a domain and a range. Very good. Here, this is a function. Only this is the symbolic representation of what a function is in Haskell. This means this is the function. Put this and the operator like this, it's a function. You can replace that with a plus, bracket plus or close bracket, then it's a function. You put a multiplication, then it's a function. This means this is of a type. Right. In mathematics, you jump around with symbols, but sometimes you are not so much concerned about their types. In Haskell, this A represents different types. It could be numbers, it could be strings, it could be Boolean. This means here the input and that input with an operator, whatever you are doing there, it will transform into an output of the same data type, of the same type. So that is what it means there. Don't be scared by symbols. Right here, semigroup instance for list. Right, let us take a collection. This means a collection. You can have a collection of oranges, collection like a group oranges in a basket. It's a collection of fruit. Money on a wallet is a collection of maybe coins. People in a, well, say in a queue, that's a collection of people. So that we can represent that A to be a collection of certain type. Right. So here, when we say an instance of semigroup collection, which is a list, where this operator now, it must implement plus plus, adding together whatever it is. Here now it gives us more power. You're not only going to be adding numbers or what, you can even join strings or other. Like you see here, this operator has allowed us to join this. See, this is going to return true. Why? Because it is associative. And this side, it is associative. If you understood what I said, then on yourself, try to write a semigroup for your own custom type. Replace this string with your own custom type. Can be Boolean, where A, B can be true, false. C, D can be true, true. Something like that. And then your own custom type representing severity, where combining returns the higher severity. So you can try this as an exercise. Right, this brings us to the next stage, which is monoid. A monoid extends semigroup by adding an identity element. So all what it means now, a monoid is an extension of a semigroup. Right, so it will have an associativity and at the same time, it will have an identity. What is identity in mathematics? An identity number is one which does not change. For example, if I say 1 plus 0, answer is 1. 5 plus 0, the answer is 5. So the 0 is an identity. It doesn't affect the other number. When you go to multiplication, an identity is not 0. Because if you say 2 times 0, then it's 0. You don't still get your 2. But it is a what? 1 is an identity. If you multiply any number with 1, whether it's negative or positive, it remains the same. So that's an identity. So now a monoid extends the semigroup, and then it ends an identity. So let me explain this class in this instance. Right, a class type, or like a class here, it's a contract. It's a contract where we say any other code that is going to derive from this class, it must use the methods of this class. But it's just like if you belong to WIMS, then implement the laws of WIMS. Then you go out, you belong to Intersect, then implement the expectations of Intersect. Then if you go out there and say, I'm an Intersect ambassador, then what do we expect? You have a contract, you are mandated to implement those Intersect items or things or laws. In this case, it is the functions. So this monoid is going to have this minimum function. So any other type that can, what do you call it, implement monoid, then it must implement this function as well as this one. Why? Because the monoid is more like a subclass of a semigroup. So a semigroup is more like a superclass. Like I have given you some examples. They may not be good for you to see. Then there are laws, 3 for a monoid. Left identity, here is an example here. You put it on the left side, you do an operation with a value, it doesn't change the value. Right associativity. Move the empty to the right side of the operator, doesn't affect, you still get the same answer. You see, this is why it's called left identity, right identity, then associativity is inherited from the semigroup. Monoid instance for list. Now let us look at a collection, because one of the things Haskell handles best are collections. And the collections are denoted by this square bracket with an A or B or whatever representing a type of collections. This could be a collection of numbers, a collection of bools, of true, false, a collection of strings, a collection of car, collection of floats, whatever. So this is what we call a polymorphic type. Right. Then here, there is mempty. What is mempty? The M there that you see is for monoid, and the empty is for like an empty set, an empty collection. So they cleverly maybe combined that word together, same empty. Then remember again this operator. We'll get back to it, because what is coming is building on the monoid. Now we jump onto the functor. Probably this word was coined from a word function. I don't know. You can research. A functor is a type constructor that can be mapped over. Right, mapping over. Now, remember we were talking about collections, a list of people in a queue. Those list of people in a queue, they are holding different money values. One has got 3, 4, maybe the other one is 10, 15, whatever. If I say, all right, can you run a function that will double the money in the places of people in a queue? I don't know if this explains this better. So actually what I'm saying is, do an operation with a function or like a machine like. It will traverse that queue, and on each element of the queue, change or upgrade the value of the money they have, either up or down. So that is a very good. We use it a lot in databases or whatever like that. Then here is a class, a blueprint. Okay. This blueprint functor F, where now F map is of this type signature. Let me explain this part here. This is saying there is only one most important function if you are implementing a functor on your own custom type. You need at least as a minimum to implement fmap. Right, let's go back to what is this fmap. Fmap is nothing but a function when you are mapping on a collection, on a data structure that you use to, what you call it, change, transform those values of a collection. There's so many words they use sometimes concerning this, but take it that it's a function that operates on a collection. So now let us look at the following here, the signature. What this means. This means that here is the function. This machine, there is a function. We say, well, how come that is a, take it, it's a function, let me put it aside. Here is a collection or a data structure. This could be a list, like you saw here, this one here. A list of things, collection of items. And then what happens when you take an element in this collection and you apply the function which you have here, it will change that type into B for each element and produce another list, which we call FB. Now the produced list out of this transformation of items, they're using a function. Right, you have got this new transformed, changed list with items that are changed inside it. Right, all this fmap is a name for this function. It does this. Right, let's go to the laws now that govern this functor. Identity. If you fmap on an ID, you just get that ID. Composition. Now, what is composition? Right, I will explain composition at this using these two, right from mathematics, composition. Right, when you have got two functions, and then these two functions, they are operating on an input. You compose them. You run one function on that input, and then you take the results, you apply the function onto that. Like for example here, I have got G composed F, G dot F, right, in the bracket. Now outside, we have got the F map. I think you remember from mathematics where sometimes if this was X with a bracket, whatever, bracket plus or times, you could say that X multiply this, do your operation, then this like this. Exactly, look at what has happened here. This F map here now is applied on G, and then it's composed, then it's applied on F. So here, what is going to run first? It is right associative, if I'm not wrong. It will start with this one, then this one will apply. Sorry, I'd like to apologize. One of the network routers just disconnected. I was busy talking about all these from semi-group monoids, applicative functors to monad. I was on monad. I don't know where I got disconnected. I'm very sorry for that. I didn't expect that. But you have got the, what do you call it? You have got the, let me put the list again, this GitHub. Let us jump into questions. I got disconnected. I don't know where and when I got disconnected. Sorry for that. Right. You can tell me, when I got disconnected, where were you? Where were we?
Afternoon, sir. You were talking about the FMAP times, I don't know, FG on your screen.
I was on FMAP. Who else remembers where I was? Because I was on the other tape, then it got disconnected. Were you with me when I was presenting? Hello? Because by the time now I realized that I'm disconnected, I was on the practical task. Let me ask once more. Is there anyone who remembers where I was here? I know our time is a little bit going, but let me just highlight what I said for the benefit of you. Where was I here?
So I think you're by number 4.
Right. Try to remember. Did you hear me explain semi-group, monoid, functor? Where was it?
Yes, so you're by
You were there, sir. Scroll up. On the
I was
last
by the functor here.
answer,
yes.
Okay. Right. Let me just quickly run through. It's short. Then I go to the applicative functor, then the monad. The functor implements FMAP. It's got FMAP function. A functor is a type constructor that can be mapped over. Like you've got a function here, and you've got an FA value type. Then you'll get back an FB. It has got two laws, identity and composition. Right, creating a functor instance of any data type, in this case, maybe data type. You need to have this check on the left side. If there is nothing on the right side, whatever value you have under that underscore doesn't affect anything. You have got nothing. So nothing under maybe is more like a what? An identity. It will just nullify everything. On the other hand, just X, then you can have this output. So I said here, implement a functor for a binary tree. This presentation has got this for you, so you can go and work on them before you take the quiz. Right. Then what is an applicative functor? An applicative is a functor with a pure. It implements a pure function. And an applicative operator, which is this one, diamond star. So the pure has got this signature. It will take a value of a type A, transforms it to, look at that F, because it's a functor A. This is a wrapped functor value. Then here is the function, the functor, the operator. This is the function, of course. This diamond star is an operator. Then this is the f function right here. This is a functor. This is a function in a what you call it, in a functorial context, which is an applicative. This second value fa, you'll get an fb. Why fb? Because of this. There are 4 laws. I spoke a lot about these laws. Identity, I can't explain now. Homomorphism, there we have it. Interchange, there you have it. Composition, there you have it. Now let us jump. Here is an example of an applicative instance for maybe. Instance applicative may be where pure is equal to just f with an applicative just x. Then what do you do here? Factor out pure. And then what do you get? You get just factored out in bracket, apply the f on x, which is the f for functor. So fx. What about here? Where any of these on this operator, if any of these, I don't know, is it a values? If they have got nothing, the outcome is nothing. Right, here's an exercise, and let's hit the last one, monad. A monad is an applicative with a return and bind. So the bind function is this fish. It's called fish, greater than equal. So here are the functions, 2 functions for a monad. Monad has got more than 6, 7 functions, but for now, the minimum required are these 2. Right, the laws are associativity and identity with respect to bind. Here is an example of a maybe with this fish operator. Right. That one, I think I have explained it. I've repeated this 3 times. Then let me explain the do notation. In Haskell, the do notation is a monadic operation. It allows us, moment you say equals do, then it allows us to create scoped in local variables like this x, this function on t, which is transaction, is going to produce tx. Then origin, this second one is going to run if this one is a success. But should it happen that this one has nothing, then Haskell is lazy. It will never bother to go further evaluating those ones. This saves memory, this saves time, saves processor time. But what happens now if this brings just something? Here we have a just value. Then this second function is going to get on this value, giving us either something, just x, or nothing. The moment it is just x or something, then this can apply there, can go to number 3. But what happens if this fails? Then remember that implicit underhood operation here is that bind. One of it fails, then everything fails. Then it will never operate on this third expression. What happens if all the 3 are successful? There is no nothing. Then you can return a tuple, which is a data structure. You can return the origin of the transaction and the destination. What does this mean? It means your transaction now has got a successful origin. You can extract where is this transaction from, which wallet address to which wallet address is it going to. So that on itself is going to be successful. So what I'm explaining to you here, this do notation with a return is a syntactic sugar for these bind operations. We have got a list monad instance. You can return x, then a list of x. But what happens if the list is bound to this because the list is there. It's not empty. Then we are going to concat map. Here is another function here, concat map. It's a variant of map. And then concat map F on the list. This XX means it's a list. It's a non-empty list. So example modeling a cell division, mitosis. I'll leave this to you to look at it in deep. Here are the practical exercises I am giving all of you who are here. Go and do these practical exercises for semi-group, monoid, functor, applicative, monad. Right. What is the good news? Please copy this. Why? Because you know me, how I am. On my other follow-up, I'm going to give you a sort of a hackathon. And then I'm going to put in some other incentives. I'm very fond of that. You know me. Put some other incentive. Unfortunately, we are not meeting next week. We are meeting after next week. I want a hackathon on a playing level competition based on this, which I have sent to you, based on semi-groups, monoids, functors, applicatives, and monads. Now, what is the hackathon? I don't call it hackathon as such. I call it marathon. Why? Because I want you to use these concepts, create a real-world application that runs, that can be tested, small. On other areas, if you go to HPM education, they call these katas. You know, when you are doing karate, there is what is called a kata, a simulation of a fight. Right. So here, I want you to make sure that you are able to create something like a kata, a marathon, using what I have sent to you, which is semi-group. I want to see in your kata or in your marathon application in real life of semi-group, monoids, functors, applicatives, and then monads. Probably go and do it now. Then when we meet after 2 weeks, we come and select the best. We give each other, you present, we ask questions, so that at least all of you now, we have given you a scope, a level field, and then you create whatever. Then I'm going to put down some prizes, some other incentives. And then I might have, when I come, a link where that all of you, maybe you click the link and then you do a quiz. Or when you do that, you put in your entries like this. Something to motivate you to do this. One, this is the key concept of Haskell. And there is no way you can dodge them. You need to just master them. That is what I am saying. Good luck for you who were here today. Here is the link again. Please copy that link. And good luck to those of you who are going to attend the next session after 2 weeks from today. So I won't announce the prizes now. I will announce the incentives or the other incentives on that very day. So if you are not attending, you won't know what you are losing. Who knows? You can win. You can be number one, number two, number three. I always prefer a broad-based, incentivized remuneration, something like ETA, rather than paying one person 10,000 or whatever. I like to spread, so encouraging more people to take part in the future. I will call it marathon presentation 2 weeks from today. So you have a motive for you to go after this. On this list that I've given you, they are tests. You see, Here are practical tests. Run them practically, and then at the end, I've got one that puts everything together, from semi-group monoid examples all the way to functor using on binary trees, and then the applicative, there it is on maybe, and then down here you go to applicative, replicate M example with IO, and then here is an example. Take this, run it. Let me run it. Where to run it now? Let me take this. Okay, let me click here. There we have it. Go to our online editor, Coxygen.co universities. When you say Coxygen.co universities, and then it will open, go to Haskell lessons, or you can go to any other, even the French, that side. Then scroll down here, there is an editor. Then write your code. It has some limitations, but for this exercise, then you can run your functions. There you are. You can see all these from number 1, 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, a monad, the test are running there. Here are the tests for this one. So already this is a template for you to go and play around with. Remember what I have said, the next coming session, I want, if we still run it the way we have after 2 weeks, then we are going to run what do you call it, a marathon. Okay, thank you very much. The attendance was humbling. Any questions? Thank you so much. Let's have some fireworks. Thank you so much. Oh, I hope it was very, very helpful to you people. I've given you the link. Thank you so much. Now, any question? Let's have some questions. You know, this is food for growth. You cannot afford to lose it. I am telling you. Any question? Any question? Question? I want to see a hand up, or any comment, any addition. Anyone here is free to add. You are free to add. You are free to ask. I see all of you are so happy. Thank you so much. Let's call it a day for today. Thank you. I really appreciate a lot. But
thank you so much, sir.
Yeah, thank you. Don't leave that link I gave you, please. And don't avoid those advanced concept Haskell. Thank you very much.
Thank you.
Don't forget to go to Intersect website, look at the subscriptions that are there. We have got a free associate one. We have got a paid one, $10. Don't worry about the $10 a year, but it will open up for you to run as a member for a committee to be elected. You can. It opens up some other things, receiving some discounted items. So this comes in courtesy, or let's say blessings of Intersect MPO. Thank you so much. I really appreciate all of you.
Thank you so much.
Thank you so much.
Thank you.
Sir.
Let's call it a day for today. Thank you.
Thank you, sir.
Thank you. Thank you so much. Thank you very much. There are some who are joining now. We are going home now. Right. Awesome. Right. Right. Let me. There are people who are still here. Are you still enjoying? I'm going to stop recording. Thank you so much.